Okay, let's jump right into this explainer and look at how life on Earth was almost totally wiped out, not just once, but 5 separate times. When we think of mass extinctions, we usually picture a giant explosion, right? Some sudden cataclysm that just wipes the slate clean in a matter of seconds. But looking at the actual data from Earth's deep history, well, the truth is often a lot slower, a lot quieter, and honestly, way more terrifying.
So our timeline here covers the 5 major extinction events: 445 million, 370 million, 252 million, 201 million, and 66 million years ago. And as we'll see, rather than just fireballs falling from space, most of these are actually these slow, deadly climate chain reactions.
Let's kick things off with the late Ordovician trap, about 445 million years ago.
At this point in time, the world looked absolutely nothing like it does today. The land was totally barren. I'm talking no trees, no flowers, not even a single blade of grass. But the oceans, they were completely packed. This was one of the richest times for sea life the planet had ever seen. The seafloor was covered in early coral reefs, strange little armored bugs crawling along the bottom, and giant squids stretching several meters long just floating through the water. But the climate was quietly setting a trap. After a long stretch of warmth, global temperatures started dropping. A massive landmass near the South Pole began growing incredibly thick ice sheets. And as that water froze, sea levels all over the planet dropped dramatically. This was super dangerous because all those ocean creatures relied on shallow coastal waters to survive. So, as the water pulled back, their habitats just shrank or completely vanished. And then, just as species started getting used to the cold, the trap snapped shut. The ice suddenly melted, sea levels rushed back up, and that melt completely changed the ocean's chemistry, choking out the oxygen in the water.
It was a brutal double blow. First freezing, then oxygen starvation. And that brilliantly illustrates the sheer scale of this disaster. Nearly 85% of all ocean species were completely wiped out. It's the second most severe extinction Earth has ever seen, and it didn't come from a dramatic explosion or an asteroid. It was just a quiet, deadly shift in chemistry. Okay, moving on to 370 million years ago, the late Devonian algae suffocation. By this time, life had made a huge leap and finally conquered the land. We are talking about the very first real forests. But the real action was still underwater. People actually call this the Age of Fishes. You had these massive reefs, some of the largest the Earth has ever built, and swimming around them were these gigantic armored fish covered in thick bony plates, almost like natural helmets, swimming right alongside early sharks. But ironically, it was those new forests on land that caused a disaster. As trees spread, their deep roots broke down rock and soil on a scale that had never happened before. That pulled huge amounts of nutrients into rivers, which then flooded the oceans. Now, you might be thinking, more nutrients, that sounds great, right? Actually, no. It triggered these massive, unstoppable algae blooms. As all that algae grew, died, and decomposed, it basically sucked all the oxygen right out of the water. And this wasn't quick either. This suffocating chain reaction stretched out over a period of nearly 20 million years. The great coral reefs were hit incredibly hard, and by the end of it, 75% of all species on Earth had perished in a completely slow-motion mass extinction. Fast forward to 252 million years ago. This brings us to the Great Permian Dive. So this was long before the dinosaurs. The land was ruled by these strange reptile-mammal cousins. Think creatures that look like a cross between a lizard and a mammal, like Dimetrodon's relatives, a group called the therapsids. Things were pretty stable until, deep underground in what is now Siberia, massive cracks in the Earth's crust opened up. We are talking about near-constant eruptions of lava and gas covering an area roughly the size of Europe, lasting for years. All that lava pumped massive amounts of carbon dioxide into the air, which spiked global heat. And the oceans absorbed tons of that excess CO2, making the water dangerously acidic. It's literally the same process as how carbon dioxide makes soda acidic. That extreme acidity completely dissolved the calcium shells of sea creatures, while the crazy global warming made oxygen levels in the water plummet all over again.
So what does this all mean? Well, this near-total planetary collapse destroyed up to 96% of all life. 96%! It was an apocalyptic collapse of the food chain, rightfully earning the terrifying name the Great Dying. It is, without a doubt, the most severe extinction in our planet's entire history.
And unlike the previous disasters we looked at where ecosystems bounced back relatively quickly, the Permian extinction was so profoundly severe that it took millions of years just to rebuild basic biodiversity. life was brought to the absolute brink of total annihilation.
Jumping ahead to 201 million years ago, we hit the Triassic-Jurassic magma split.
Earth had finally recovered, and it was dominated by these giant crocodile-like reptiles called pseudoseuchians, freely roaming across the giant supercontinent of Pangaea. But then, right beneath their feet, Pangaea violently began to rip itself in two. This splitting crust unleashed crazy amounts of magma and carbon dioxide, triggering huge volcanic activity across the separating continents. The sudden, terrifying climate shifts that followed were just too much for those giant reptiles. They needed way too much food and simply couldn't adapt. But somehow, small, agile dinosaurs, possibly because they were warm-blooded and fast-growing, managed to survive the freezing volcanic winters that followed.
When the smoke finally cleared, 76% of species were gone, including all of the dinosaurs' biggest competitors. Suddenly, the path was completely clear for dinosaurs to take total control of the world.
Which brings us to the most famous one, 66 million years ago, the asteroid that changed everything.
By now, massive creatures like T-Rex and Triceratops are thriving. You've got giant pterosaurs with wingspans like small airplanes, and 42-foot marine reptiles hunting in the seas. Imagine a totally normal afternoon for these animals that had ruled for over 150 million years. Herds are just grazing. Then suddenly, a tiny point of light, sharper than any star, appears hanging in the daytime sky.
Slowly, hour by hour, it grows brighter and bigger. It doesn't even really seem to move much across the sky, it just gets larger, turning from a tiny pinprick into a visible glow as the animals literally pause their grazing to look up. In a matter of seconds, that glow became a massive ball of light. A staggering asteroid, somewhere between 6 to 9 miles wide, slammed into the shallow waters of modern-day Mexico with the unimaginable force of billions of nuclear bombs detonating all at once. The impact triggered an immediate chain reaction that is honestly hard to even comprehend. The shockwave vaporized hundreds of miles of rock instantly. A global wave of heat swept across continents, igniting forests thousands of miles away. But the real killer? The aftermath. The impact threw so much dust and ash into the atmosphere that it blocked out the sun for years. Without sunlight, the plants died. Without plants, the plant-eaters starved. And eventually, the giant predators starved right along with them. It was a complete collapse of the food chain. When the ash finally settled and the skies cleared, 75% of all species were gone forever. Every single non-bird dinosaur, animals that dominated the globe for over 150 million years, just vanished in a geological blink of an eye.
But hiding safely down in the wreckage and underground burrows were these tiny, rat-sized mammalian survivors. With their giant reptilian competitors totally wiped out, our distant ancestors finally had the room and resources to grow, adapt, and spread out across the planet.
And that leaves us with a truly mind-bending final thought for this explainer. If that one random space rock, traveling through the vast emptiness of the cosmos, had altered its trajectory by just a fraction